We're going to continue with multiplying matrices, but we're going to look at one other part of matrices from section 4.4 called finding the determinant. So first we're just going to recap how to multiply matrices. So I'm trying to solve for A and B here. So I'm multiplying two matrices and this is my solution. So remember, multiplying matrices is row 1 by column 1, okay, and that's this entry. So I know I want to include that because that one involves A. So remember, that's 5 times -4 plus A times -3 plus 5 times 3 has to equal row 1, column 1 is 1, 1, so -14. So I can solve this now for A. Sorry, that's a terrible looking one. There we go. So I've got -20 plus 15 is -5 minus 3A equals -14. Add 5. So -3A equals -9. So A then has to be 3. We can do a really similar thing for B. So I just need to involve column 2, and it doesn't really matter. I could use row 1 since I now know A is 3, or I could use row 2. I'm going to go ahead and use row 2. All right, so row 2, column 2 has to be 22. So I'm going to do 1 times 2 plus 5 times 4 plus 0 times B. Oh, and that's not super helpful, right? Because then B disappears. So I am actually going to choose then to use row 1 because 0B is not going to help us. Okay, so let's do this one. So we now know A is 3. Okay, so I have 5 times 2 plus 3 times 4 plus 5 times B has to equal, now we're talking about row 1, column 2, which is going to be -3. Okay, so we get 10 plus 12 is 22. Subtract 22. So B then must be -5. Okay. Question, in this expression, if A is a 3 by 5 matrix, then what could be the dimensions of B? Remember, we can only define matrix multiplication if the number of number of columns in the first matrix matches the number of rows in the second matrix. So 3 by 5 can multiply by 5 by anything. And remember, matrices aren't going to have decimal fractions or negative numbers, just a natural number. So it has to be a 5 by any natural number. Natural number are just our counting numbers. 1, 2, 3, 4, 5, on and on. Okay? By any natural number. Okay. So now we're going to look at the new vocab for today called the determinant. So it must be a square matrix. So again, square just means same number of rows as it is columns. So for example, a 2 by 2 matrix is a square matrix. The difference of the products of the diagonals is how we define the determinant. So you might be like, why do we even care about the determinant? Well, matrix theory and application goes actually quite far. So the determinant can be related to area or volume of a region, and it reflects how the linear transformation associated with the matrix can scale or reflect objects. So what matrices do, you guys, is they transform different objects. So the determinant is related to a certain transformation. It can also, which we're going to use it for, help us determine the solutions to a system of equations. So that's how we're going to apply the determinant. So first we need to know how to find it. Okay, so the determinant of A can be notated like this, DET, or they can use the absolute value bracket. So if we're referring to a matrix, the absolute value symbol means determinant. So here's the matrix here, so it can be written like this or like this. And here's how we find it. We do the diagonals multiplied and we subtract them. So we do A times D minus B times C. So here I would be doing 1 times 8 minus 4 times 5. So the determinant here would be 8 minus 20 or -12. So the determinant of this matrix is -12. Here I would do 1/2 times 2 minus -1/2 times -1. So I would get 1 minus 1. Oh, I'm sorry. 1 minus 1/2, which is 1/2. Okay, so the determinant is diagonal 1 minus diagonal 2, multiplying those entries on the diagonal. Okay, so find the determinant here. So we have 1/2 of 2 pi minus 1/4 times 1/8. So half of 2 pi is just pi. Here I get minus 1/32. And I would leave it like this, you guys, just for exact form. Oh, I'm sorry. I don't know why I did 1/4. I'm reading things. This should be 4. So 4 times 1/8, or 1/8 of 4, is 1/2. So you can think 4 over 8 and then reduce. Okay, so diagonal 1 multiplied minus diagonal 2 being multiplied. Okay, so here I can see those absolute value brackets. That's asking about the determinant. So they're saying the determinant of this matrix equals 16. What did k have to be for that to be true? So I know that k times 0 minus k squared times 2k has to equal 16 if we're following that determinant definition. So k times 0 is just 0. So here I get negative 2k to the third power equals 16. I'm going to solve for k. Divide by negative 2. And the cube root of negative 8 is negative 2, right? Negative 2 times itself 3 times equals negative 8. All right. Okay, I am just actually going to show this one to you guys. Maybe I'm not. No, I'm not. All right, that's okay. Okay, so 2 by 2 is really not bad, right? We do diagonal 1 minus the product of diagonal 2. So here's how we would do a 3 by 3 by hand. And I have to warn you guys, this one is really tough. So we would multiply, sorry, not multiply. We're going to follow this definition here. So there's 2 different ways we can do that. Here's one description here, and here's another. I tend to like this one a little bit more. I'm just following those first 3 entries in row 1, and I'm essentially creating 3 2 by 2 matrices and finding the determinant of each of those. And we know finding the determinant of a 2 by 2 matrix really isn't that difficult. So I'm going to look at entry 1 here, A1, and I'm gonna like cross out the row and column that it's in, and here's my 2 by 2 matrix. So notice it's this entry times, sorry, I shouldn't put a matrix, I should just do, well, actually I will. I'll write it longhand. So I'm going to use the bracket, the absolute value bracket for determinant. So I'm finding the determinant of this matrix. Okay, and then it's minus, so now I'm moving to the second entry. Okay, and I'm kind of crossing out the row and column it's with, and then I'm finding the determinant of that remaining entry. Okay. Okay. So I have 5, 3, 1, 8, and then I have that 4 in front, that entry that I took out. And then our last one is plus C1. So now I'm looking at the last entry in row 1, which is 1. And then my remaining matrix, 2 by 2, is 5, 2, 1, 4. So now I'm finding, sorry, that kind of got fuzzy. There we go. So now I'm finding the determinant of each of those, just like we did before. Diagonal times itself, subtract the other diagonal. So I'm going to do 2 times 8, 16, minus 3 times 4, which is 12. So I'm going to get 2 times 4 there. 5 times 8 is 40, minus 3 times 1 is 37. Okay. 5 times 4 is 20, minus 2 times 1 is 18. Okay, and then I can finish this guy. Negative 4 times 37 Looks like we get negative 148 there. Plus 18. So here I'm going to get, let's see, negative 140, negative 122. So negative 122 would be the determinant of this 3 by 3 matrix. Okay. I am going to show you guys, so there will be portions of this assessment that you have to do by hand and portions you can use your calculator on. So I'm going to show you how to enter a matrix onto your calculator, and you can actually use your calculator to help you find the determinant. Again, 2 by 2 is not overly difficult. Anything above 2 by 2 gets definitely more challenging. So I'm going to show you how to do that. So the first thing you guys want to do is right here above the x to the negative 1, you can see the word matrix. So if I go to second and then matrix, you can edit each matrix. So I scrolled to the right to hit edit, and I'm going to use matrix A, and right now it's a 3 by 3. So I'm going to hit enter, and this is going to allow me to change it. So for example, if I wanted to find the determinant of this matrix, okay, I'm going to enter these values in. So it is 3 by 3. If I want to change it, I would just type the number, okay, but I don't, so I'm going to keep it as 3 by 3. And I'm just arrowing over to those entries, okay? So here, sorry, I'm trying to get it so I don't have a bunch of glare there for you guys. Okay, so I'm going to enter this matrix. So I have 2, I'm just hitting enter after each one, and then it moves entries. So I have 2, then 4, enter, 1, enter. Now it moves to row 2, 5, enter, 2, enter, 3, enter, 1, enter, 4, enter, 8, enter. Okay, so now I have matrix A defined as how I want it to. So I'm just going to second quit. Okay, so now I want to find the determinant of this matrix. Okay, so I'm going to go back into the matrix menu, so second matrix, where it says math. These are all different operations or functions we can use with matrices. So I want determinant, DET, and then I want it of that matrix A that I just edited. So I'm going to go back in one more time and select A. So I just hit enter as soon as A popped up. So I'm finding the determinant of A and hit enter, negative 122. So good way to check I did my math correctly. So you can use your calculator to help you find the determinant, especially if it's more than a 2 by 2. If it's a 2 by 2, it's probably not worth it because it takes that much time to enter all those entries before you can find the determinant. So doing it by hand is much quicker. A 3 by 3 or a 4 by 4, 5 by 5, this is a great strategy. Okay, guys, that is everything for this video. Thanks so much for watching.